varying energy output from the sun. But the crucial question is whether that's the cause of the recent rise in global temperatures, basically over the last 40 or 50 years. 27 years ago, a paper was published with very strong evidence for exactly that. Egil Friis Christensen and Knud Lassen at the Danish Meteorological Institute looked at the pattern of solar activity over the last 250 years, and it matched almost perfectly with global temperature changes. But closer examination of the data revealed a flaw. To get their graph, Friis Christensen and Lassen had to filter the data. That basically means smoothing it out to account for background variation and local anomalies. This is standard practice, and they did that for most of the graph. But they didn't do it for the most recent part of the graph because the data needed to do it wasn't available at the time of publication. When it did become available, the graph showed a very different story. A very good correlation between global temperatures and solar output over most of the last 250 years, but not the very period that covers a dramatic rise in global temperatures. While global temperatures have been rising, solar activity has remained more or less static. Since the 1991 paper, a number of other research papers have been written, and nearly all confirmed what the revised Friis-Christensen-Lassen graph showed. Solar activity explains most of the temperature changes over the last few hundred years, but not the recent period of rising global temperatures. But there's one more thing to check before discounting solar forcing as an option. All the historical data measuring the amount of solar energy falling on the Earth are derived by secondary methods. Sunspot counts, levels of carbon-14 and beryllium-10, for example. To get a measure of the sun's exact output, you have to go into space, away from all the meteorological clutter on Earth.